In 1865, the great physicist, James Clerk Maxwell published his work on electromagnetism, which basically states that visible light is just a section of a whole spectrum of electromagnetic waves which are propagating waves of electric and magnetic fields traveling perpendicular to each other, thereby implying the existence of other frequencies of light. 23 years later, a 31-year-old physicist by the name Heinrich Hertz was experimenting in his workshop trying to prove Maxwell's theory, when he discovered a wave of light, one which is invisible to the naked eye and frequency much less than that of the light that was known by the time. Some notable items he worked with were an induction coil, a spark gap, an interrupter, a receiving antenna and a cell or battery. The induction coil is basically a soft iron core wound by an insulated wire called the primary coil, on top of which another insulated wire called the secondary coil is wound. The secondary coil usually has many turns compared to the primary coil. The ends of the primary coil were connected to the cell, which provides EMF that circulates current in the primary circuit. This current in the primary coil produces a magnetic flux which in a way causes an induced EMF in the secondary coil whose ends are connected to the spark gap. However, both the current in the primary coil and the induced voltage in the secondary start up small and slow and rises till it reaches its peak value, but when the primary current is suddenly interrupted, it causes a sharp change in the magnetic flux, which in turn induces a very high but also very short EMF in the secondary coil. As a result, the secondary coil which is connected to the spark gap then causes a short spark to occur in the gap in between the two electrodes in the device. Whenever this happens, Hertz would observe another spark in the spark gap of the receiving antenna he had placed about 1.5 meters away, implying that waves produced by the spark in the induced coil and its spark gap had somehow traveled to the copper wire receiver, thereby creating a spark there as well. The main experiment was more complicated than this though. Hertz would measure the velocity and frequency of this wave and come to the conclusion that it was an electromagnetic wave, thereby confirming Maxwell's theory. Heinrich Hertz becomes the first person to produce and detect a radio signal. Though the radio wave was discovered by Hertz, he had no intention of making commercial use of the big discovery. This would be realized by Guglielmo Marconi. At an early age, Marconi was intrigued by Hertz's work on the radio waves and pondered how he could turn it into a more useful and profiting invention. Now, the telegraph, which was the main device for distant communication in the world at the time, had several problems, such as it would often distort messages, it required numerous wires and poles for its connection, and so on. Marconi wanted to invent a system in which communication would be done wirelessly over long distances, and he intended to accomplish this using the radio wave. When he was just 20 years old, Marconi began experimenting with radio waves. He would assemble his working tools in the attic of his home. Soon enough he constructed a storm alarm using a coherer, which was a radio detector, a battery, and an electric bell. During storms, he would position the device in a suitable location such that when lightning struck, radio waves from the strike would be received by the gadget, after which the bell on it would ring, signaling the detection of the wave. With the help of his parents, Marconi would continue reading and learning more about the invisible light through the works of physicists at the time who were experimenting with the wave. Soon enough, with relentless experimenting, Marconi came up with an efficient device. Using a simple oscillator, a capacity area, a telegraph key, a coherer, and a telegraph register, he built a radio system that operated without wires. Fundamentally, Marconi's device involved an oscillator or radio transmitter which would produce and emit radio waves through an antenna. The waves would then be picked up by a coherer, which was a radio signal detector invented by Edouard Branly in 1890. The radio signal received by the coherer would then be interpreted and recorded in a paper by the telegraph register. The telegraph key, which is essentially an electrical switch, is used to transmit Morse codes across the system in the form of electrical pulses. So the radio is basically a telegraph, only instead of electric currents and wires it makes use of electromagnetic waves, radio waves to be specific, and the vacuum or air. At first, Marconi's device could only operate within a distance of half a mile, which was a big issue that even several other inventors at the time were facing with inventing the wireless telegraph. Marconi knew that if he really wanted to get his work recognized and profitable, he had to improve it, especially the length at which it could perform. In 1895, he discovered that if he raised the length of the radio's antenna and ground its transmitter and receiver, he could extend its distance of operation to 2 miles. Marconi, who was an Italian, tried obtaining a patent in his native land, but when he applied for one, he received no reply. Persistent, Marconi sought help from his family friend, Carlo Gardini, who introduced him to Annibale Ferrero, the ambassador of Italy in London. Through Ferrero, Marconi was able to in 1896 get a patent in Britain instead. His patent was titled, "Improvements in Transmitting Electrical Impulses and Signals, and in Apparatus Therefore." He would go on to perform demonstrations of his new invention in Britain. Soon enough he began getting international attentions. He soon traveled to the US, where he demonstrated and obtained numerous patents also. Guglielmo Marconi would go on to commercialize his invention, receive a Nobel Prize in Physics in 1909 for it, and would go down in history as the father and inventor of the radio. Since the invention of the radio, the device has been used in many areas of life, including communication, navigation, remote control, and many others. In fact, without the radio, modern day as we know it would not be the same. Thanks for watching.